Good day all. Today we'll be looking at an example under commutation. Now our question says the armature of a certain dynamo runs at 800 RPM. The commutator consists of 1, 2, 3 segments and the thickness of each brushes is such that the brush spans 3 segments. Find the time during which a coil of the armature remains short-circuited. Now, the question is demanding for our what? For our time of commutation or our commutation period, and denoted as what? TC. Now, TC is given to us as WP, which is the width of our brush, minus WM, which is the width of our mica insulation if given, and over our peripheral velocity. Now, the width of our brush wasn't given to us. It wasn't given to us. Instead, we are told that our brush spanned 3 segments, and that of the mica wasn't given, so we'll be neglecting that. So our width is meant to be in form of a length, something like cm. It's supposed to be in units of length, that's in meters or centimeter or millimeter, but what we were given is what? 3 segments. Now, for us to better understand this, I will be making a rough sketch to explain what this question is asking of us. Now, let's say this is our commutator having each segment up to what? 1, 2, 3 in number, and we know that at the magnetically neutral axis, that is where our brush normally used to be, so they're telling us that our brush covers about 3 of them. Our brush is encoded about 3 segments. They are covering about 3 segments. So since we don't know what our width is, we can still work with these 3 segments given to us. But the impact it will be having is that our peripheral velocity will be expressed in terms of segments per second, so we can get back our unit for time, which is what? Seconds. So what I'm saying here is that the unit for this, if we're taking it to be 3 segments, whereas we are taking our unit to be what? In segments. So segment is on top, and our velocity must be in what? Segments per seconds, which can also be written as your segments over your segments times seconds. This cancels out and you're left with this in what? Seconds. So our aim is to express our peripheral what? Velocity in terms of what? Segments per what? Seconds. So we are given our speed or velocity to be what? 800 RPM. We are given, this is what we are given, this is our known speed. Now, for us to express it in terms of segments per seconds, we will first convert this into revolution per seconds. So in revolution per seconds, we have converting N to RPS. We have that 800 will be divided by what? 60. And if we do that, we have 13.3 revolution per watt seconds. Revolution per watt seconds. Now for us to change our revolution into segments in a single revolution, our a segment of your commutator comes in contact with your brush. So if we are having 2 segments, we're multiplying the whole segment by our speed that is now in revolution per seconds, in order to get to express this our speed or our velocity in terms of segments per watt seconds. So multiplying this value, your 13.3 times the number of watt segments, this will give us sorry, 1635.9 segments. Okay, if you approximate this is 56. Segments per seconds. So we have succeeded in converting n into this v value. Now that's just the idea. For you to for you to use your v, you always be giving n instead. First of all, break it down to revolution per seconds and multiply whatever you have gotten from this to the whole any parameter that describes the whole the whole segments. It can be in segments, it can be you can be giving diameter, you can be giving angle, but anything that describes that total number of segments, you multiply it to get your v. So after getting our v, we can now simply impute our value. Remember, our wn wasn't given to us, so this will be 3 over 1636, and you have this to be equal to 1 point, let's say, 83 milliseconds. So that's the value for our commutation time, or time of commutation. So thank you and God bless you. Please subscribe to the channel and see you in the next video.